Welcome all to today's lecture. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The lecture series I am covering is for the subject Microprocessor. Code is KCS 403. Today I will be discussing Microprocessor 8086 pin diagram. It is a 40 pin IC, and as we can see that these pins, this is the ground, first pin is the ground, these pins 2 to pin number 16 is AD0 to AD14, that is the multiplex lower order address and data bus. And these are the two categories of signals ranging from pin number 31 to pin number 24, which have been categorized according to the mode, operating mode of 8086. So the pins for the maximum mode are these, and the pins for minimum mode are these. So now here, this is interrupts, clock, ground. These are certain pins which we will discuss in subsequent slides. These are again address lines, the rest of the address lines A16 to A19, since we are having 20 bit of address bus in 8086. So this is AD15, this is AD15, this is VCC, bus high enable and minimum and maximum. So I have already discussed when telling about the minimum and the maximum mode in the previous lecture that this pin is used to set the microprocessor in minimum or maximum mode. So if you want to set a microprocessor in maximum mode, then this pin should be 0, and if in the minimum mode, this pin should be 1. 8086 operating modes. So these are two, minimum and maximum, I have already discussed. In minimum mode, what is the significance of this? That 9 signals correspond to the control signals that are needed to operate memory and input output devices connected to 8088. In maximum mode, 9 signals change their functions, and 8088 now requires the use of 8 to 88 bus, or you can say this is just a family 8086 also. So in maximum mode, not only our microprocessor 8086 is used, but along with it there can be other processors available. So we need 8288 bus controller to generate memory and input output read and write signals. So this is how the operations take place in the case of maximum mode. So why do we use these two separate modes? So in minimum mode, signals can be directly decoded by memory and input output circuits, resulting in a system with minimal hardware requirements. But in maximum mode, systems are more complicated, but obtain the new signals that allow bus grants, that is the DMA, and the use of 8087 coprocessors. So there can be any other coprocessor also. So this is the pin description. This is the lower order address, multiplexed address and data bus. When AD lines are used to transmit the memory address, the symbol A is used instead of AD. For example, A0 to A15. So these lines are used to carry the address. When data are transmitted over AD lines, the symbol D is used in place of AD. So for data, D is used, that is the data bus is used. It can be D0 to D7, D8 to D15 or D0 to D15. Rest of those signals are these multiplexed, and the second functionality of these pins is the status pins. Higher order address bus, that is A16, 17, 18 and 19. These are multiplexed with status signals. So these S5, S6, S4 and S3, these are the status signals. So what is the role of bus high enable? It is used to enable the data onto the most significant half of data bus and D8 to D15. So when when the D8 to D15 is enabled, so using this pin bus high enable D8 to D15, that is a higher order data bus is enabled to carry the data. 8-bit device connected to upper half of the data bus use BSG signal. It is multiplexed with this data signal S7. What is this minimum and maximum mode? I have already explained. This pin indicates that what mode the processor is being operated on. Read. This signal is used to read operation. It's an output signal. It's an active when low. So this is active low signal, and it should be at logic 0 to indicate the read operation which performed in the 8086. Now we come to test. So we first of all we are studying those signals which are common to both the modes. So after this read signal we come to test signal. These are the common signals to both the modes. Test is input is tested by the wait instruction. So this signal is used along with the wait instruction. 8086 will enter a wait state after execution of the wait instruction and will resume execution only when the test is made low by an active hardware. So whenever the instructions with the prefix wait are encountered in the programming, in the coding, so the processor enters into the wait state whenever the instruction with the wait prefix comes. So after entering the wait state, the CPU remains in that state only until there is a active there is a high signal on the test pin, that is the until the test signal is activated by some external hardware. So in this way this pin is used to test the condition whether the processor is in wait state or not. So it is used to synchronize an external activity to the processor internal operation. Now we come to ready pin. This is the acknowledgement from the slow device or the memory that they have completed the data transfer. So as I have already discussed while teaching 8085, that whenever we connect the peripherals with the microprocessor, maybe those peripherals are not as fast as the microprocessor. So to synchronize with the slow peripherals, this pin is used. So this is the acknowledgement from the slow device that that particular device is ready to establish the communication with the processor or to make the data transfer. The signal made available by the devices is synchronized by 8284A clock generator to provide ready input to the 8086, and the signal is active high. Reset. This causes the processor to immediately terminate its present activity. So after the reset, all the present activities going on in the microprocessor are terminated. It must be active high for at least 4 clock cycles, then only the microprocessor gets reset. So at least for 4 cycles this signal must be high. Clock input provides the basic timing for processor operation and bus control activity. It's an asymmetric square wave. Asymmetric because the duty cycle of clock used in 8086 is 33%. So it looks like this. So this, suppose this is the full, this is the T. So about 2/3 of the period of clock, this is high and otherwise low. So 33% is the duty cycle. Sorry, for only 1/3 it is high and the rest is low. In this way it looks. So this is the duty cycle. Next is INTR interrupt request. This is a triggered input. It is sampled during the last clock cycles of each instruction. So after at the last clock cycle of each instruction, this signal is sampled to see if any interrupt has arrived or not. So if any interrupt request is pending, the processor enters the interrupt acknowledgement cycle, because it accepts that interrupt if any interrupt is available during the sampling of the signal, and then it sends interrupt acknowledgement signal. So this signal is active, high and internally synchronized. Now we come to the minimum and maximum modes respectively. So first of all, we will talk about these modes. So in minimum mode, the microprocessor do not associate with any coprocessors and cannot be used for multiprocessor systems. In maximum mode, 8086 can work in multiprocessor or coprocessor configuration. Minimum or maximum mode operations are decided by the pin minimum and maximum active load. So this is what I have already discussed, and when this pin is high, 8086 operates in minimum mode, otherwise it operates in maximum mode. So here we will discuss these modes one by one, the pins related to these modes. So pins 24 to 31 distinguishes between the two modes. These 24 to 31 pins are separate for both the modes, and for minimum mode this pin should be logic high. So 8086 itself generates all the bus control signals in this mode, and these are the control signals. Let's see these signals one by one. First of all, DT oblique R bar, this is the data transmit oblique receive, output signal from the processor to control the direction of data flow through the data transceivers. So this controls the data flow through the data transceivers. Data enable, that is DEN, is another signal in this minimum mode. This is again the output signal from the processor and used as the output enable for the transceivers. So this signal determines the direction of the transfer through the transfer of the data through the transceivers, and this signals enables the data transmission. Now address latch enable, this is again used to demultiplex the address and data lines, as similar to the role that was in the 8085. So that is address latch enable. Now this is to state that whether the operation performed by the 8086 microprocessor is read or write, and that is related to the memory or is the input output operation. So when the microprocessor is performing some memory operation, so this is high, otherwise it is low. It is used to differentiate memory access or input output access. For memory reference instructions it is high, and for input and output instructions it is low. See, so these are the two instructions which are used in the input output ports. Now the write operation. Write control signal is low whenever the processor writes data to the memory or to the input output device. So there are only two possibilities: either the processor can write data into the memory, or it can also write into the input output device. So in both the cases, write operation will be performed, and this signal is asserted low because this is active low signal to indicate the write operation. Now this is interrupt acknowledgement. When the interrupt request is accepted by the processor, output is low on this line. Why low? Because this is active low. So this is used to indicate the acknowledgement of interrupt. Now we come to the hold pin, that is the hold pin, pin number 31. This is the input signal to the processor from the bus masters as a request to grant the control of bus. So basically this is the part of DMA operation. Whenever some other master device needs the control of all the buses of the processor, then it sends some request through the DMA controller to the processor. So if that request is acknowledged, then only the processor relinquishes all the buses and another master can use those buses. This is how the DMA operation is processed. Now what is the role of hold signal? That through the hold signal, the DMA controller will send the request to the microprocessor to relinquish the bus and allow the access for the buses to the another master. So this is usually used by DMA controller to get the control of bus. So now what is the role of HLDA? This is the acknowledgement to this signal, acknowledge signal by the processor to the bus master requesting the control of the bus through hold. Acknowledge is asserted high when the processor accepts the hold. So when the processor accepts the hold signal and acknowledges it, then the acknowledge is asserted high. And what about these signals? Now we have come to the maximum mode. In the maximum mode, again pin number 24 to 31 have the different roles, different from those discussed in minimum mode. So first of all, we will discuss these status signals. These are used by 8086 bus controller to generate bus timing and control signals. How? Let's see. So these are the combinations for these signals, that is S0, S1 and S2. So when these three are 000, interrupt acknowledgement machine cycle is identified, and when this is 001, read input output port, 010 is write input output port, 011 is halt, 100 is code access, 101 is read memory, 110 is write memory, and 111 is inactive state. So in this way, these status signals determine the status of the machine cycle or the status of the operation which is being performed in 8086. Now, this is the these two pins, that is QS0 and QS1, pin number 24 and 25 indicates the queue status. So, the processor provides the status of the queue in these lines. It can be used by external device to track the internal status of the queue. So, how the internal status is determined? Let's see. That if QS1 and QS0 is 00, then it means that no operation is being performed in the queue. If this is 0 and this is 1, that means the first byte of the opcode is being fetched from the queue. Now 10 indicates that queue has to be emptied. So it determines the subsequent byte from the queue has to be fetched. So this is the status of the queue which is determined by the condition of these two pins. Now we come to another pin, that is pin number 30 and 31. So this is the bus request or bus grant. So RQ stands for bus request and GT stands for bus grant. There are two signals, that is signal 0 and signal 1. Priority among these two, higher priority is for RQ/GT not. So this is prioritized. And these requests are used by other local bus masters to force the processor to release the local bus at the end of processor's current bus cycle. So this is the request to the processor to suppose in the maximum mode many bus masters are there because many coprocessors are working in the maximum mode. So if another master needs the bus for it needs the local bus from another master. So how will it put the request? So this is the way of putting the request, that it will send the request signal through this. Suppose one master is connected to RQ/GT0, another master is connected to RQ/GT1 signal. Now through both the lines, some other masters have sent the request for the local bus to the processor, and at the end of the processor's current bus cycle, then these signals are sampled and these pins are bidirectional. So request is also sent through these lines and also acknowledged through these lines. So the request on GT0 will have the higher priority in GT1. So what will happen? Suppose both the masters are sending the request through these lines. So the master connected to GT0 will get the bus access prior to the another one. So in this way it will get the acknowledgement first, and the another master which is connected to RQ/GT1 that will receive the acknowledgement thereafter. So in this way these pins are used to request the bus control as well as they are used to get the acknowledgement of the bus access. So now we come to the lock signal. It's an output signal activated by the lock prefix instruction. It remains active until the completion of the instruction prefixed by lock. Suppose the processor come across such instruction where the prefix lock is used. So now what will happen? For that, while executing an instruction with the prefix lock, it will prevent other bus masters from gaining the control of system bus. So for the duration of that particular instruction which has been prefixed by this lock instruction, lock signal, then what will happen, that any other master will not be able to get the access of the system buses during the execution of that particular instruction, which has been prefixed with this. So, output signal is activated by the log prefix instruction. So, in this way this signal is used. So, here I have discussed all the pins, all the common pins which are common to both minimum and maximum mode, as well as then we discuss the minimum mode pins which are connected to only the minimum mode, and lastly we discuss the maximum mode signals. So, in this way we complete the pin out of 8086. We will study the further topics related to 8086 in subsequent lectures. Thank you.